Hello and welcome to the question series of ISRO. In this video, we'll see the questions of 2017 and the questions of mathematics. So let's take the questions. The first question we have: if f of t is given as e to the power of at, then for s greater than a, the Laplace transform of e to the power of at is. Your options are a by s square plus s minus a, then root pi upon s minus a, 1 by s minus a, and then does not exist. Very simple question. L of e to the power of at, we know that it's nothing but 1 by s minus a. So L of e to the power of at is equal to 1 by s minus a, direct formula based question. So the option C is correct. We have another question. Second question we have: evaluate double integration from 0 to 1, 0 to 1, 1 upon root under of 1 minus x square, 1 minus y square, then dx, dy, and your options are given pi by 2, pi by 4, pi square by 2, and then pi square by 4. Let's solve it. Double integration. So as we can see, यहाँ पे हम लोग क्या देख सकते हैं? We can see that the limits of this x and y we have from 0 to 1. So whether you integrate it with respect to x or with respect to y doesn't matter at all. So first I'm integrating with respect to y. So let's say this is 0 to 1. If I'm integrating with respect to y first, then this x portion will be taken out. So I'll be writing here 1 by root under of 1 minus x square, integration 1 by root under 1 minus y square, this will be dy, and once we solve this entire integration has to be solved with respect to x. This is 0 to 1. So let's solve the inner one. 1 by root under 1 minus x square, and integration of this is what? This is sine inverse y, right? So this is sine inverse y, put the limits from 0 to 1, and then dx. If you put here root under 1 minus x square, what is this? Sine inverse 1 minus sine inverse 0. So this will be pi by 2, and then dx. This pi by 2 will be taken outside. So pi by 2, integration 1 by root under 1 minus x square dx from 0 to 1. This will be again sine inverse of x, and if you put the limits from 0 to 1, it will be again pi by 2. So here we have pi by 2 multiplied by pi by 2, which is pi square by 4. So the correct answer is option number D. Okay. Then we have question number 3. Question number 3 we have: if A equals to matrix is given as 9 6 8 7, then they are asking, tell me what is determinant of a to the power of 99 minus a to the power of 98. This is my question. So let's solve this. Solution says, we know that if I'm interested to find this determinant of a to the power of 99 minus a to the power of 98, I can write this as determinant of a to the power of 99 minus determinant of a to the power of 98. This could be written as determinant of a whole to the power of 99 minus determinant of a whole to the power of 98. So for this we need to know the value of this determinant of A. So determinant of A is what? 7 9s are 63 minus 48. Here we have 15. Okay, so here you can put 15 to the power of 99 minus 15 to the power of 98. If you take this 15 to the power of 98 as common, this will be 15 minus 1, which is 14 into 15 to the power of 98. This is your answer. Then we have question number 4. Let's write question 4. Question 4 is limit log theta minus pi by 2, theta minus pi by 2, as theta tends to pi by 2, and this is divided by tan theta. I need to solve this. Is your option A is 1, option B is pi by 2, option C is pi by 4, and option D is 0. Simple question. If you substitute theta is equal to pi by 2 here, so this will be log 0, which is infinity. So this tan pi by 2 is also infinity, so this is infinity by infinity form. So we'll be applying Hopital rule. If we apply this Hopital rule, then we need to differentiate this numerator and denominator with respect to theta. So first, if you differentiate this, this will be 1 upon theta minus pi by 2, and then d by d theta of this will be simply 1, and then we have d by d theta of tan theta is sec square theta. Great. Now this could be written as what? This could be written as 1 by sec square theta is cos square theta, and then this is theta minus pi by 2. Again, if you substitute theta as pi by 2, cos 90 is 0. This turns out to be 0 by 0 form. Again, I'll differentiate this. So differentiation of this is 2 cos theta multiplied with minus sin theta. Then this will be 1. Okay, now if you substitute theta as pi by 2, so cos 90 will be 0. So the answer is option number D. Then we have question number 5. Let's write question number 5. What do we have? Yes, we have a differential equation. Ordinary differential equation is given. Is asking y dx plus x dy equals to 0, and they are asking what is the solution for this. So y is equal to k by x, y equals to k by y minus x, then y equals to x by y, and then we have option D as y is equal to e to the power of kx. As from this question, as you can see, with this could be easily solved using separation of variables. So I'm solving this and I'm writing y dx is equal to minus x dy. I can separate the variables. I can write easily as, let's say, dx by x is equal to minus dy by y. Now if that is this case, then I can simply integrate this. This will be ln x is equal to minus ln y plus ln c. Now here we have ln x y plus, this will be ln x plus ln y, which is ln xy, and this is ln c. Remove this natural logarithm from both sides. We can write this xy is equal to c. So y is equal to c by x. C is anything, and c you can put k. So here I am putting c is equal to k, which is k by x. Let's see, y is equal to k by x, k by, yes, option number A is correct. Then what do we have? We have question number 6. We have question number 6. Question number 6 says, if phi is a scalar point function, if phi is a scalar point function, the value of curl grad phi, the value of curl grad phi, the value of curl grad phi is what? Is option A. Option A we have 0, then we have 1, and then we have 2, and then we have 3. Okay, fine. Now you should remember that this statement, that is curl grad phi, is always 0. There is no doubt in that. So it's quite easier for us to learn this, that is curl grad phi of anything is 0. But let's see how this has come. So this phi is a scalar function. So what is this grad phi? So if I'm writing grad phi, this grad phi means I cap times we have dou phi upon dou x plus j cap dou phi upon dou y plus k cap dou phi upon dou z. That's the meaning of grad phi, that is the gradient of this. Now curl of grad phi, it means I need to get the determinant of I cap, j cap, k cap, then dou x, dou y, and dou z. Here I'll be having dou phi dou x, dou phi dou y, dou phi dou z. Now if you solve this determinant will actually come out to be 0. And it is quite suggestible that remember one statement, that is curl grad phi is equal to 0. That's it. Now let's see question number 7. Question number 7. Yes. The point where the plane x plus 3y plus 2z minus 6 is equal to 0 meets the line joining P211 and Q, where the plane meets the line joining P211 Q13 minus 2 is option A is 211, option B 111, option C 13 minus 2, and then we have option D minus 1 3 2. Okay, so the question says the point where the plane, I have got a 3D plane out here and it meets the line joining this. So let us consider we have some plane, any random plane I have taken, and the equation for this plane is x plus 3y plus 2z minus 6 equals to 0. Now there is this plane is actually meeting a line. So let's say we have got a line and this plane is cutting this line, and this line points we have as P and Q. Let's say this point is R. The point P coordinates are given as 2 1 1. The point Q coordinates are given 1 3 and minus 2. R coordinates we don't know. Alright, so R coordinates we actually don't know. So let us consider this R coordinates has to be, say, X, Y or Z, maybe any coordinate. You can assume this to be A, B, C or X, Y, Z, anything. Now if this is the line, then what is that equation of the line? So what is the logic that we have to apply? First I will be finding the equation of this line. So I'll be writing here equation of line PQ. And the more easier part is to write the equation of the line in terms of symmetric form. So we know that the equation of a line is x minus x1 by x2 minus x1, and then better I should write here x1 y1 z1, or anything, maybe say. In order to avoid confusion from this, I'm simply writing a, b and c, no problem. So here I'm writing x minus x1 by x2 minus x1, and this has to be equal to y minus y1 by y2 minus y1, and this will be equal to z minus z1 upon z2 minus z1. Great. Now here we have x1 y1 z1, here we have x2 y2 z2. Now you can write this x minus x1, so this points I can simply write x minus x1 is 2, then x2 is 1, this is 1 minus 2, okay. Then we have y minus y1, so here I'll be writing y minus y1, which is 1 divided by 3 minus 1, and this will be z minus z1, so that is z minus z1 is 1, z2 is minus 2, and then minus 1. Okay, no problem. So here we have, what do we have here? Better you keep it x, y, z itself, otherwise some more variables will come into picture. So I'll be writing x minus 2 by, this is minus 1, and this is y minus 1 by 2, and this is z minus 1 upon minus 3, and let's say this is k, say. Great. Now here, from here I'll be finding this x, y and z in terms of k. So I can write that x minus 2 is equal to minus k. X minus 2 is equal to minus k, because minus 1 and k is minus k. Then we have y minus 1 is equal to 2k, and then we have z minus 1 is equal to minus 3k. So from here we can write that x is equal to 2 minus k. This is my first coordinate for this point. Then we have y is equal to 2k plus 1. Great. Then we have z minus 1 is equal to, this is z is equal to 1 minus 3k. Cool. So here we have got this coordinates of x, y and z as 2 minus k, 2k plus 1 and 1 minus 3k. But one thing you should note here, that since this point falls on this plane, then this point has to satisfy this condition. Alright. So we'll be substituting these all values out here, and we'll be getting the value of k, and then we'll find the values of x, y and z. So that's the thing. So using this expression in place of x, I'll be writing 2 minus k. So let me write 2 minus k, and then we have plus 3 times y. What is y? It's 2k plus 1. So 2k plus 1, and then we have plus 2z, so which is 1 minus 3k, and then we have minus 6, and this is equal to 0. So 2 minus k plus 6k plus 3 plus 2 minus 6k minus 6 is equal to 0. So from here 6k and minus 6k gets over. Then we have, what do we have? 3 plus 2, 5 plus 2, 7 minus 6, 1. So 1 minus k is equal to 0. So from here I can write k is equal to simply 1. So once we have got the value of k, substitute here. So x point will turn out to be 2 minus 1, which is 1. Y value will be 2k plus 1, which is 3. And z value is 1 minus 3, which is minus 2. So your correct answer will be 1, 3 and minus 2. That is, it means that this plane is nothing but this point itself. It's passing through this particular point. So this option will be your correct answer. So option number 1, 3 minus 2, that is option number C is your correct. Great. Now we have question number 8. We have question number 8. Question number 8 says integration from 0 to pi by 2 sine 7x dx. I need to solve this. You can solve this in so many ways. There are different ways also, gamma function, beta function and all, but I'll be using some different method. So here we have the options is 8 by 35, then we have 16 by 35, option C we have 0, and option D we have as 1. So you should remember this formula, that is integration from 0 to pi by 2, whether you solve it for sine nx dx, This will be equal to integration 0 to pi by 2, and this will be cos nx dx. This will be equal to, remember this, n minus 1 by n multiplied with n minus 3 by n minus 2, then n minus 5 by n minus 4, and so on, 1 by 2 multiplied with pi by 2. This you have to apply when n is even, and then n minus 1 by n multiplied with n minus 3 by n minus 2, n minus 5 by n minus 4, and this will go up till 2 by 3 multiplied with 1. Okay, and this how you have to apply if n is odd. So let's check whether n is even or odd. So here we have n is odd, so I'll be applying this. So I can write integration from 0 to pi by 2 sine 7x dx. This will be 7 minus 1 by 7. 7 minus 1 by 7 multiplied with 7 minus 3 by 5. Then we have 7 minus 5 by 7 minus 4, which is 3. And the last we have reached, that is 7 minus 7. So this will be 7 minus 6, of course. Here it will be coming 2 by 3 and then 1. So this is 6 by 7 multiplied with 4 by 5 multiplied with 2 by 3. So 3 2s are 6. Then what else? Here we have 4 2s are 8 2s are 16 divided by 35. Any option? Yes. So option number B is correct. So the answer for this is this one. Then we have question number 9. Let's solve question number 9. Question number 9 says, again a direct formula base, that is L of t cos of at. This is your question. Simple, you can simply solve it as minus d ds of L of cos at. I'm not going more into deep because all these things you have, you know it. So the answer for this will come out to be s square minus a square by s square plus a square whole square. So this is your correct answer. That's it. Then we have question number 10. Let's go. Question number 10. It's given that a vector is 3i cap plus 4j cap minus 7k cap. Money. Then we have b vector is equal to pi cap minus 6j cap plus 3k cap are perpendicular. Find p. Find p. See, from this you can judge the level of the questions. That is, questions are not very difficult. It's very easy, simple. You need to know some certain fundamentals. We have two vectors and they are perpendicular. What is the logic that we need to apply? We know that a vector dot b vector has to be 0. If that is so, then I'll be writing 3p, then minus 24, minus 6, and this 24, and then we have minus 21, and this is equal to 0. So 3p, this will be what? 4 plus 1, what is this? 4 plus 1, 5, and then 4. So p is equal to 15, I guess. This should be the correct answer. Yeah. Let's check once again. 3p, then we have minus 6 4s are 24, then 7 21, 4 1 5, 2 2 4, p is equal to 15. Yes, fine. P is equal to 15. Then how many questions more left? Yes, one single question left. You can say this an aptitude question, or rather maths aptitude, whatever you say. We have question number 11. He's telling the arithmetic mean arithmetic mean of 12 data points is 79. Then later it was found that the two data points were wrongly taken as 83 and 63 in place of 78 and 97. Actual mean is your option A is 79, 75, 81, 77. Great. Very simple question. Arithmetic mean of 12 data points. So let's say we have 12 data points. Let's say from x1 plus x2 and so on till x12 divided by 12. They are telling that the arithmetic mean is say 79. And again he's telling that later it was found that the two data points were wrongly taken as 83 and 63. So let us consider those two data points as to be the last 2 points. You can assume anything. So here I am writing it, modifying it and writing again. Then we have writing 10 points and then 83 plus 63 divided by 12. This value was actually 79. Fine. Now from here what I will do is I will write x1 plus x2 dot 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 till x10. This will be equal to what? 79 into 12 minus of 83 minus of 63. So if you solve this, you will get as 802. What our task is? Our task here is to find the actual mean. That means I have to replace these two numbers with this. So I'll be writing x1 plus x2 and so on till x10. I'm replacing this, so the new numbers updated, that is 78 plus 97 divided by 12. I need to know the value for this. But we know that x1 till x10 is 802. That is from here to here, the value we know it's 802. So this is 78 plus 97 and then if you divide it with 12. So if you solve this, you will get as 81.466, which is roughly around 81. So here you need to tick one correct option, which is 81. So this is your option number C. So yes, we have finished all the questions of ISRO 2017. See you in the next video for the questions of 2016. Till then, bye bye, take care.